Okay, we're going to go through the first two solutions for graphical motion models. Alright, so here we have this position versus time graph. The object is at a negative position. If I look at it later, it's at the same negative position. Later, it's at the same negative position. The object is sitting still. So that means that its velocity, which is the slope of this graph, is 0 for the entire time. The motion map, it's to the left of the origin here if we call positive to the right. So let's say it starts here, and then it stays here, it stays here, it stays here. I just moved the dot up so that you can see that, so that it doesn't, it's not on top of the other ones. Okay, second one. Now we have the same looking graph, but it's a velocity graph this time instead of a position graph. So since the velocity value is the slope of the position graph, what we see here is a negative constant velocity, which means we should have a negative constant slope on the position graph. So this graph could do that, this graph could do that, that graph could do that. All of these position graphs would give you that velocity graph. They all have a negative constant slope. It doesn't matter which one you pick here. If you want to know which one it really is, you'd have to be given more information. You can't get the initial position from the velocity graph, only the change in position. So what we have is the object is moving at constant velocity. I know it's constant because, well, two reasons. This graph here is constant, and then the slope there is constant. And it's moving in constant velocity in the negative direction. So we have to pick a direction called positive. It's moving the other way. I just chose arbitrarily that it was starting at a positive position. So I'll have it move maybe 1.5 clicks. I'm just making up a distance here. Arrow, arrow. Okay, so this is how our object is moving from the right to the left if we choose positive to the right.